Alright, we're going to begin the next lesson, which is on finding the greatest common factor of a polynomial. And we need, for this objective, we need to find a common monomial factor given a polynomial, whatever that may be. So first, let's take a look at some terms. We have a monomial, which if I go ahead and, let's say I put down 7z to the third power. I just want to give an example of a monomial. This is a number, variable, or product with non-fractional exponents. And it can be positive or negative. The idea is that it can only be one term. There's no other monomial being added or subtracted with this. So we can leave it as 7z to the third, or you can write it as negative 7z to the third. Now, for a polynomial, that is a sum or difference of terms or monomials. So I'm going to use the example 8x to the third minus 24x squared plus 8x. So you can see that we're subtracting or adding. It doesn't matter if you're adding, it doesn't matter if you're subtracting, but the fact that you have more than one term is the key idea there. And we can now take a look at what the greatest common factor is between those, but let's define that first. The greatest common factor, which can be abbreviated as GCF, that is the greatest term that can be divided from, so I'm going to write that, divided from, or is a factor of each term in a polynomial. Now if we use the polynomial that I wrote down, then we can take a look and see what is divisible from all three terms. You look at the coefficients, 8, 24, and 8. All of them are divisible by 8. Now if we look at the variables along with that, x to the third, x squared, x. All of these have an x. So all three terms can also divide by x to the first power as well. So the greatest common factor in this is 8x. Now let's take a look at the first example. Now let me scroll down. Give me a second, sorry. Okay, there we go. Now for number 1, since we're looking at 18p to the 5th power b squared plus 12p cubed b to the 7th, we want to find the greatest common factor of this binomial. Now what we want to do, if we are trying to find that GCF, again, first, if you look at step 1, you want to see what coefficient can be divided from, for example, 18 and 12. The highest number is 6. So if we take 18 and 12, they're both divisible by 6. Now when we look at the variables, let's start with p to the 5th power and p to the 3rd. The rule on finding the greatest common factor for variables is you always take the lowest of the group. So because when we look at these and compare, p to the 3rd power, that is the one that is the smaller of the two numbers. We can actually use p to the 3rd as part of our GCF, and then now we can move on to the b's. So we look at b squared and b to the 7th power. Between those, the lowest of them is b squared. So b squared will also be included in our greatest common factor. So the answer to number 1, all it says is find the GCF. And when you look at this whole problem, 6 p to the 3rd b squared is as much as you can divide from that entire polynomial. So that would be our answer to number 1. Okay, now just to check, if you wanted to actually divide I'll show you, if we divided 6p to the third b squared from the binomial, this is how it would look. You'd have 6p to the third b to the second. Now, reverse distributing, which we're going to learn as factoring soon, when you divide that from this, we would ultimately get 18 divided by 6 is 3. Now, if I subtract the exponents, I would have p 5 minus 3 is 2, and then b squared divided by b squared. That cancels out. So then we have plus, and if I take 12 divided by 6, that would be 2. P to the third divided by p to the third is canceled out. And then b to the seventh divided by b squared, that is p to the, subtracting, fifth power. So, if you'll take a look on the inside of this polynomial, or the 3p squared to, oh, I did put p, didn't I? My bad. That's supposed to be b to the fifth power. Okay. Looking at that, you can see 3 and 2 no longer have any factors in common. P squared and b to the fifth. Those do not share anything as well. So, that's how we can determine that 6p cubed b squared was indeed the greatest common factor of that polynomial. Alright, so that, again, is our answer. Now let's go down to, gosh, bear with me. Okay, let's go down to the next example. And let me scroll a little more. Okay, for number 2, we want to find the greatest common factor of this. So, as I look through the problem, I want to know between 24 and 8, the coefficients, what are both of them divisible by? They are both divisible by 8. So, the greatest common factor here is 8. That's the first part. We're not done. We still need to find the greatest common factor of the variables. So, moving on to x first, looking at x cubed and x squared. The lowest exponent of those is x squared. So we have 8x squared so far. Now let's take a look and see, what about y? Well, we have this y. Remember, that's y to the first, and this is y squared. Again, as often as you need to, put the 1 in so you know exactly what's correct. Because we have y to the first versus y squared, we can also include y to the first in our GCF. Now you guys know from listening to me that 8x squared y would be the official answer to this if you're looking for the finalized answer. Now I know in the previous one I did show what it would look like if we factored, but right now all we're identifying is what is the GCF. Okay. And let's move on to the last example. So, let me scroll up a little bit so we can see it. But okay, now with this example, you'll notice that we're starting with a negative coefficient. Our leading coefficient is negative 12. When we are looking at, it doesn't matter what it is, and I'm not going to ask you to reorder these. Keep it in the order that it's presented in. Because our leading coefficient is negative, your greatest common factor should indeed have a negative answer. So, when we look at negative 12 and negative 36, the greatest common factor between those, well, both of them are divisible by negative 12. Okay, moving on to the variables. We look at y to the third compared with y squared. Those both share, or both are divisible by, the lowest of y squared. So we can include that. And then when we look at z to the 8th versus z to the 9th, we know the smaller exponent is z to the 8th power. So our answer to that one is negative 12 y squared z to the 8th power. Hopefully this seems simple enough, but if you have questions, please make sure to ask. Okay, now I do want to scroll down a little bit before I let you pause and try out the individual activity. Please note, and this is very important, if a variable does not exist in all terms, then it cannot be included in the greatest common factor. What does that mean? It means if I'm looking at this trinomial down below, you see how we have 5x to the 5th y cubed plus 20x to the 3rd y squared minus 15y squared. There is a variable missing in this trinomial. Where is there a variable missing? In the back. This one does not have an x in between the coefficient and the y variable. If there is not an x in the problem, you cannot factor any form of x from that trinomial. Not even x cubed. So, if I'm looking at what is the GCF, some of you might have already begun writing that down, and what I would say, okay, 5, 20, and 15 are all divisible by 5. We look at x to the 5th, x cubed, but no x in the last term. So we cannot use x in the GCF. Now we move on to the y's. We look at y to the 3rd, y squared, y squared. All three of these have y at least. So when we look at the lowest exponent, we can include y because it's in all three terms. So the GCF here is 5, and then we look at y to the 2nd power. Remember, we're always going with the lowest exponent, but it has to be a variable that is present in each term in that trinomial or polynomial. Alright, so that is our greatest common factor for number 3. Now please pause so that the students may work on the bottom 6. Okay, now we're going to continue, and we're going to take a look at the answers from the guided practice. Just to make sure, when you look at number 1, 35t to the 7th, 20t to the 3rd, and minus 5t squared. With those, the GCF is 5t to the 2nd power. Okay, now for number 2, looking at that one, 12, 18, and 24 are all divisible by not 12 because of that 18 in the middle. But they are all divisible by 6. And when we look at the variables, all of them can be divisible by k to the 1st. But again, as soon as you can, I want you to just leave it as 6k. Okay. Moving on to the next two. Number 3, that would actually, here I'm actually going to scroll down all the way so we can put both, all 3 and 4. Okay, now with 3 and 4, again, 3 starts with a negative, so we have to include a negative, which is negative 8. And looking at the r's, both of them have r's. It's going to be r to the 1st power, s to the 4th, and t. That's our answer for number 3. For number 4, looking at these, all 3 are divisible by 9. Comparing c's, the lowest exponent is c to the 1st, and then d to the, looking at 8, 6, 2 is the lowest exponent. So 9c d squared is an answer for number 4. And finally, we get to the last two. With number 5, we can see, again, this starts with a negative, so we have negative, and then looking at 16, 18, and 44. Not all of those are divisible by 8. 44 is not, so we have to use negative 4 at the most. Then we have e to the fourth power, f to the third, and g to the second power. And then for number 6, sorry, let me put a little check mark so we know that one's correct. Number 6, when we look at that, 36, 60, and 24, all of those are divisible by, we know they're divisible by 6. You can check and see, well, what about maybe 8 or 12? If you did put 6, that's true, but it's not the greatest common factor. 36, 60, and 24 are all divisible by 12. So the GCF here, like 36 divided by 12 is 3, 60 divided by 12 is 5, and 24 divided by 12 is 2. Okay? So now looking at the x's, we have x squared, and we have y. All three have y, so we're looking at y squared. And z, that'd be z to the fourth power. Alright, we've made it through another lesson, and here's to the assignment. Good luck.